Okay guys, so in this video, we're going to look at the Unit 2 Independent Task 4. So usual things, you should have had a go at these 5 questions, and you should have got to the certain level of support that you needed. Now remember, if you didn't need any support, that's excellent. Just keep this taken away in the background ready for your exam. If you got to level 1 or level 2, that's a topic that requires a small amount of work, just to maybe a bit of a recap, a couple of extra questions. If you get into level 3 or level 4, then that's a topic that requires a lot of extra work on top, okay? So let's walk through each question. The first one we had was Poisson distribution. So independently for each page, the number of typing errors per page in the first draft of the book has a Poisson distribution with a mean of 0.8. So part A, calculate the probability that a randomly chosen page contains at least one error. So we're talking about the average per page. So the first thing I need to do is define my letter, because it's not defined in the question. So I'm going to do let x equals, okay? This is going to be the number of, okay? It's always number of for a Poisson or a binomial. So number of typing errors per page. Okay, which means I can then write my Poisson distribution as 0.8, okay, because that's what it is per page. So for part 1, I wanted the probability of at least 1, which would be greater than or equal to 1. Okay, so that obviously I can't do, so I need to change it. That's 1 minus it being 0. That's the only one that this doesn't involve. Okay, now you could have used your calculator. However, when we get a PD, so an equals to, we should try and use our formula. So I've got e to minus 0.8 times 0.8 to the power of 0, all over 0 factorial. Now, both of, so this is equal to 1. This is also equal to 1. So I can just use the e to the minus 0.8. Type in my calculator. I get 0.5507, which if you use the PD function as well, you should get the same answer. Now for part 2, calc the probability that the third page of 3 randomly chosen pages is the first to contain 1 error. Okay, so I'm going to choose on the probability that the third page has the first error. Okay, so to do that, the first 2 pages have to not have any errors. Okay, so that would be the opposite to what I just found there. So that's 1 minus 0.5507. That's the probability of the first one not having any errors. And I want the probability of the second one doesn't have any errors. And then I want the third one to have at least 1 error. Okay, so the first one's no errors, and then having at least 1. Now if I type again all that in my calculator, I get this as an answer. Now part B, a little bit different. Write down the probability Pn that a randomly selection of n pages contains no errors. Okay, so if I'm thinking about how this is going to work, if I think about 1 page, okay, so the probability of no errors on 1 page, that's going to be me doing, okay, e to the minus, as we said it before, that is just e to the minus 0.8. So I said before, the 2 bits in yellow I've got here, they become 1, so it's just this. Okay, now I want that for n pages. Okay, which would be this to the power of n. That's me having the first page times the second page times the third page times the fourth page times the fifth page and so on, about however many I want, okay? Which I can rearrange. I can use my laws of indices. It gives me this. Okay, I don't know what n is, so I have to leave it as that. Now part 2 wants me to find the smallest value for n such that Pn being less than 0.001. Okay, so I'm going to say that this is less than 0.001. Okay, I need to solve that. Now, this does include some of your pure working bits, okay? You need to do the opposite to your e by here, which would be your log. So I'm going to have natural log of 0.001. It's going to be less than minus 0.8n. Okay, I'm going to solve that. So that means n must be greater than 8.63, which means the smallest value for n should be 9. If you're not 100% sure about that exponential stuff, it's probably because you may have not completed it in Pure yet, but that's how we use it. Okay, so that's just a quick reminder. You should have seen something like that when you first did Poisson a little bit. Okay, number 2, we have hypothesis testing. So Charlie is given a coin and he is told that it is biased. So the probability of P of obtaining the head is tossed as 0.75. To test it, he uses these hypotheses, determining hypotheses. Okay, he decides to toss the coin 50 times and he donates the number of times he gets obtains a head by X. He defines the critical region as this, so he's done all that bit for me. Okay, so I know that if I'm using his X, it should be binomial 50 and 0.75 I'm going to use here. Okay. Now I got rid of part B here because we don't need it. So there's just 2 things I need to do. Determine the significance level. So to determine the significance level, I'm going to work out what's the probability of each of these happening. Okay, so on the probability that X is less than or equal to 31, I'm looking at what that probability is. I'm going to probability that X is greater than or equal to 44. Okay, now the first one I can go straight to my calculator and it's going to give me 0.0287, whereas this one here, I'm going to have to do 1 minus the probability that X is less than or equal to 43, which comes out as 0.0194. Okay, now my significance level is simply going to be adding these 2 up. So 0.0287 plus 0.0194. Okay, and I'm going to plug that in my calculator. It gives me 0.0481. You could change it into percentage if you want. Okay, but generally we can just leave it as a decimal, unless it states otherwise. Now, for the next one, find the probability of accepting H0, okay, if the P is actually 0.5. So I'm going to use P as 0.5 here. Okay, now the probability of accepting H0, okay, would it be being between, if my critical region is being less than or equal to 31 or greater than or equal to 44, so that's my outside ranges, accepting H0 would be between those 2 ranges, which would be it being greater than or equal to 32 or less than or equal to 43. Okay, because 44 is included in it, so I have to go down 1, and same thing, 31 is included, so I have to go up 1. Okay, so this is, if I split this up, this is being less than or equal to 43, take away the probability of being less than or equal to 31. Okay, now from there, okay, we're just going to get our calculator and we're going to work them both out separately. Now the only difference with this scenario is that I'm going to use my new binomial is going to be 50 and 0.5. I'm not using 0.7 this time, okay? So if I type it being less than or equal to 43, I get 0.999999996, okay, which is rounds to 1, okay? If I type this in my calculator, I get 0.9675, and I'm going to take them away. So I get 0.0325 as my final answer. Okay, make sure you be carefully rounding. We always do 4 decimal places. So if it rounds to 1, write it as 1. Don't feel like you have to force it to be this really long decimal. Okay, number 3. The number of hours of sunshine in a day Y for a month in July at Heathrow are summarized in table below. So I've got my table here. I've got my group frequency table. A histogram is drawn to represent this data. Okay. Now, if I'm looking at this group here, the 8 to 11 one, okay, so that would be, if I have my histogram 8 to 11, okay, the bar has a width, so this width here is 1.5, if I have my bar, and its height would be 8. Okay, so I'm going to use that proportion to help me with the other ones. Okay, so calculate the width and height of the 0 to 5. That's this first one. Okay, now the width is the easy one. So we're going to deal with the widths first. Okay, if I look at the 8 to 11 one, okay, this one, okay, if I look at the class width is 3. Okay, it's 3 hours is the class width. And this telling me that is represented by 1.5 centimeters. So to go from that one to that one, I've halved it. So if I look at the same one, sorry, if I look at the 0 to 5 in the same way, this is 5 hours, the class width. So that means if I'm using the same proportion, this should be 2.5 centimeters in width. Okay, so my width is 2.5 centimeters. Now the height is a little bit harder because with the height, we use frequency density on the histogram, which means I'm actually going to look at the areas first. Okay, because area represents my frequency there, so I can use that. Okay, so the area of the first one of this bar would be timesing my length and height. So 1.5 times 8, which is 12 centimeters squared. Okay, so that area, this is for the 8 to 11 group. Okay, that area 12 centimeters squared represents a frequency of 8. Okay, that's the frequency by here. So I'm going to try and find out what a frequency of 1 represents. I'm going to use that then on the other one. Okay, so if I divide by 8, I get 1.5 centimeters squared. Okay, and again, I can use that same proportion to help me now. So if I look at the 0 to 5, okay, and I look at the area, my area should be, if the frequency for 1 is 1.5 and I've got a frequency of 12, I'm going to do 12 times 1.5. Okay, which gives me 18 centimeters squared as my area. Now I also know what the width is. Okay, so if I know what the width is and I know what the area is, I can work backwards here to find the height. Okay, so my height would have to be 18 centimeters squared divided by my 2.5 centimeters of the width. Okay, which gives me 7.2 centimeters as my height. Okay, so I have 2.5 as my width and 7.2 as my height. Now part B says, use your calculator to estimate the mean and standard deviation of the sunshine. So we can use our calculator here. So we go to menu and 6. I want one variable, so number 1, and it comes up with your x, and you should have your frequency column there. Now for your x values, you must use the midpoints. Okay, when you're doing this. Okay, then from there, as long as I use my midpoints and I type everything correctly, I should just be able to spit out my 2 values. Okay, because it does say I can use my calculator. Okay, so I've got 6.63 and I've got 3.69. Now, if you went the long way about it and you did the whole formulas, that would be completely fine as well. You should have got the same answers. Right, so now we've got some mechanics. The first one, just velocity time graph and using it a little bit. So vehicle A travels on a straight horizontal road. It passes point A at time 0 and is moving with a constant velocity of 18 meters a second. It continues to travel at a velocity of continues to travel at this velocity for 48 seconds. It then decelerates at a constant rate for the next 12 seconds until it passes B with a velocity of 3. Okay, so sketch a graph for this. So when you're sketching a graph, a velocity time graph, it doesn't have to be to scale or anything like that. Okay, as long as you label your key points. So at time is 0, okay, it's going to be at a speed or velocity of 18 meters a second, and it's going to travel at that constant velocity for 48 seconds. So I like to put some dotted lines in. This helps me do this. 48 seconds. It's then going to decelerate. So that's going to be a line going down for another 12 seconds. That's until 60 seconds. okay? And it's going to decelerate until it reaches a velocity of 3. So it's going to come straight down like this until it hits a velocity of 3. And there you go. There's my key points. I don't need to do anything more. Let's just label things. Velocity in meters a second. This is time in seconds. So I don't need to write S on both of these two now. There you go. Right, part B. Find the magnitude of the deceleration. So that should be your gradient of this line here. Okay, your deceleration or acceleration is your gradient. So gradient for that section. Okay, now it's talking about deceleration, so I don't need to include a negative. It should be my change in y, my change in x. So my change in y is 18 minus 3. My change in x is 12, because they told me it was 12, and also I could take these two away. Gives me 1.25 meters per second squared. Then part C is the distance from A to B. So that's all the way from the beginning of my graph to the end of my graph. Now your distance should be your area under the graph. Okay, so I've split into two shapes. I've got this first shape, which is a nice rectangle. So that would be 48 times 18. And I've got the second shape, which I could split into two, but it is just trapezium. I've got my vertical length as my parallel lines. So I've got a half 18 plus 3, because it's my parallel side, times my height, which is between 48 and 60, which is 12. Okay, if you split into a triangle rectangle, that's fine. You should end up with the same answer, but we do need to be able to spot those trapeziums. They can be really, really useful for ourselves. We got the final one. We got some kinematics of Suvatsev. What I always recommend you do is, even if it's just moving in a straight horizontal line like this one, it can be really important to just draw a line and just label some key points. So a car is traveling along a straight road, ABC, with a uniform acceleration slash double arrow of A. The distance A to C, so A to C should be my last points. Okay, this distance there, which I'll do in a different color, is 460 meters. The time taken for it to go from A to B, so let's say A, B is here, for sake of argument. The time from A to B is 6 seconds, and then the time from B to C is 14 seconds. Now, clearly mine's not to scale, but I'm just trying to label my key numbers on. The velocity at A is u, so u here. And the speed when it passes B, so velocity here, is 17. Find the values of A and U. Okay, now you can kind of probably see here that I've got two unknowns. If we're getting used to this kind of like question, we're probably going to have to use some simultaneous equations. But let's set some things up first. So the first thing I'm going to consider is the whole thing. Now I can do the whole thing because the acceleration is constant or uniform for the whole thing. If it was different for the sections A to B and B to C, I'd have to split them up. Okay, but if I look at Suvat now, I'm moving at a constant acceleration. That's why I can use Suvat. S is 460, because that's the whole way. U is U, don't know what it is, but I can write it down. V, I don't know. I don't really want to know what it is at C. A is A, and time is the total time, which would be 20 seconds. Now, if I'm thinking about what equation to use, the one without V in it is S is ut plus a half at squared. And I can plug things in. So I've got 460 is 20u, and then a half of A, or half of at squared, is going to give me plus 200a. Okay, which I can simplify down a little bit to help me out here, but I could leave it as that as well. So 23u plus 10a. I've divided them all by 20. Okay, look, I've got two unknowns, kind of as we expected. So this is from A to C. I looked at the whole thing. Okay, the next thing I'm going to look at is A to B. Okay, and I'm going to again write Suvat out, and I'm going to go from there. Okay, so I don't know my distance. U is U. I know what V is because it's 17 when I get to B. A is A, and T is 6, so I don't care about S. Okay, so this equation would be V equals U plus AT. So I've got 17 is U plus 60. Okay, that's my second equation. I'm now going to do simultaneous equations. So u's are already the same. So I'm going to do number 1, take away number 2. It's going to give me 6 is 4. Sorry, that should be a by here. Is 4a. So that means a must be 1.5 meters per second squared. And then I can find the corresponding u value as well, okay, by substituting it back in. Okay, it doesn't matter which one you sub it into, which one you prefer. Should get 8 meters per second. Okay, so set up some things with Suvat. I always recommend you draw a little diagram, even if it's on horizontal one, just so you can label your key points. Now, apart from that, make sure you've marked that and you've made a note of all the level of support that you need. But I will see you in the next video. Thank you, guys.